Hello everyone and welcome back. In this video, I'm going to introduce energy. First, I'm going to talk about the different types of energy you will deal with in a first-year physics course. And toward the end, I'm also going to introduce the single most important concept in this topic. Now, before we get into any of that, let's start with the definition. So, like force, energy is such a fundamental concept that defining it isn't very easy. If you looked in the dictionary, it would tell you something like you need energy to go do something, walk around the house, lift something, etc. There's another basic definition you'd find in the dictionary, but it uses a word that's actually very important, especially in the physics sense, and we're going to talk about it today, which is exactly why I'm not going to mention the definition because all it's going to do is confuse people. So to keep it simple, we're going to define energy like this. Energy, a transferable property of a system that can neither be created nor destroyed. Now, this last statement you may have heard. Energy can neither be created nor destroyed. That means the amount of energy the universe started with is the amount of energy it has, period. It will neither be gaining any more of it or losing it. This is also why energy, in terms of human civilization, is so valuable. So let's introduce the different types of energy we will be dealing with. First up, gravitational potential energy. Energy stored between the Earth and another object. This is probably the first type of energy human beings ever actually used, or stored. This is the type of energy you store if you lift something off the ground, or if you were to climb a ladder onto the roof of a house. Keep in mind, this type of energy requires two objects, whatever you are lifting and the Earth. Basically because the whole point is that object you lifted wants to get back to the Earth, and that object and the Earth will pull in each other, just like I showed you in our force gravitational video. The second type of energy we'll be dealing with is kinetic energy, the energy of motion. Basically, any object that has mass and velocity has kinetic energy. Not to be confused with momentum, which is what we just did. The third type of energy we'll be talking about is elastic potential energy, the energy stored in a spring or elastic object. So this is energy stored if you pull back a bow to fire an arrow, if you pull back a spring in a pinball machine, or if you squeeze a tennis ball and then watch it pop back into shape. The fourth type of energy that will come into play is called internal energy. This is also known as thermal energy, but I'm leaving it in this phrase because this is what the College Board prefers for the AP1 exam. This is energy transfer due to friction. For the sake of this course, we're going to define this as the energy transfer due to friction, because it's really the only time we will be using it. So if you were to rub your hands together on a cold winter day, you would notice they would warm up. That, in a nutshell, is internal energy. Now, before we get into detail on any of these, we're going to talk about the single most important concept in this topic. And that is not the actual energy itself. It is the transfer of energy. So in order to talk about that, I'm going to bring up this grid. This represents force, this represents displacement. I'm going to take this, put it in the corner, because we're going to use this as part of our discussion. So we're going to do a few mental experiments here. And in our experiments, what we want to do is break a piece of chalk. So in this situation, I have a white piece of chalk, I have a table, and I have a book. Now the idea is I want to store energy in this book so it can break the chalk. What am I going to do with it? Well, I'm going to take the book and I'm going to lift it into the air. Now if you think about it, I'm storing energy by lifting the book. I'm separating the book from the earth. So I'm storing energy between the book and the earth. It requires both objects. So the truth is the energy isn't just stored in the book. The energy is stored between the book and the earth. So for this situation, the book and the earth are in my system. Now, I lift the book upward. In order to do that, I literally have to exert a force upward on the book. Now, to break the chalk, I would need to drop the book, but that's not the part I really want to look at here. What I want to look at is how do you store energy in the system? Let's step back to where the energy comes from. Well, the energy comes from you. It comes from your lunch, whatever you ate. You eat food to gain energy. By lifting the book, you're transferring that energy from your body into the system. So you need to exert a force upward, and the displacement of the book needs to be upward. This type of energy you're storing is gravitational potential energy. Let's take a look at another situation. In this case, I have the chalk leaning against a wall here. I want to use this cart to actually break the chalk. Well, I'm going to take the cart. What direction would I push it? I would push it this way, to the left. So force would be this way, and of course, this object would speed up to the left. So displacement would also be in this direction. Now, in the first situation, the system would actually have energy stored in it even if I held the book above the table and nothing was moving. But here, this cart is gaining a different type of energy. It's gaining an energy because it is increasing in velocity. So in this case, force is to the left and my displacement is to the left. And since this card is increasing in velocity, the type of energy this should be gaining is called kinetic energy. Let's take a look at our third situation. In our third situation, I want to use an elastic object to break the chalk. And what I'm going to do is take the chalk, I'm going to put it in a slingshot. The green band here is my elastic object. Now, to store energy in the slingshot, I need to take the chalk and I need to pull backward. So this is the direction of the force. And of course, this is also the direction that the slingshot's going to stretch. So this is also the direction of my displacement. I can pull this back and hold it here. And as long as I hold it here, there will be energy stored in the elastic band. If I let go, the energy will be released, but that's not the part I'm concentrating on right now. I'm concentrating on storing the energy. So in this case, I need to pull to the right, and the displacement of the chalk will also be to the right. I'm storing energy in the elastic band, so this type of energy is called elastic potential energy. Now, the one thing I want to note about my grid is that in order to transfer energy, I need the force exerted and the displacement to be in the same direction. If I push the book up and the displacement of the book goes up off the table, I'm storing gravitational potential energy between the book and the earth. If I push the card to the left and the card increases velocity to the left, I'm transferring kinetic energy into the cart. If I pull the slingshot band to the right and the slingshot band stretches to the right, I'm storing elastic potential energy in the slingshot band. In other words, this relationship is what is required in order to transfer energy. And even though you will deal with situations about the energy types individually, most of what you deal with in this topic will not be based on the energy types individually, it will be based on the transfer of energy, which leads us into the second most important definition in the course. Now, this one is interesting because it uses a word that we use in our everyday language all the time, except how we use it in physics is a little different and much more specific. The word is work, and the definition is a transfer of energy to or from the system. And just like some other definitions we talked about, this definition is deceptively simple. Notice the fact that I have transfer of energy underlined. So this is not energy. This is a transfer of energy, literally how much energy has transferred to or from your system. And this is an extremely important concept. It means in our situation, by lifting the book, the amount of work done would be how much energy was transferred from your body to the book Earth system. When the cart was pushed, it would be how much energy was transferred from your body into the cart as kinetic energy. When you pull the slingshot back, it's how much energy is transferred from your body into the elastic band of the slingshot. However, if that elastic band was already pulled back and it was given to you and you held it there would be no energy transfer because that band would not have gained or lost energy. So I'm going to end with the mathematical relationship, but we'll deal with the mathematical relationship in the next video. The mathematical relationship looks like this. Work is force parallel times displacement, just like I have up here. All these forces and displacements are parallel. They all happen to be in the same direction, which doesn't have to be true for it to happen either, but we'll talk about that next time. Basically, work is a dot product between force and displacement. But these are the two things that are required if you want to transfer energy to or from the system. Again, this was an introduction, so I'll leave examples for my next video. Other than that, have a good day. This is Mr. M, signing off.